Okay, what the receiver operating characteristic curve is, it's a graph of where you take the x values at the cut points is 1 minus specificity, and you graph that against the y values or sensitivity. So I just pulled this into Excel. So what I did is I first put in the sensitivity and specificity values as I calculated them. I'm going to ask you to calculate the 9 and make sure that these numbers are correct. But for this hyperthyroidism example, for each cut point, I can have a sensitivity and specificity. I can make an x value, which is 1 minus specificity, and the y value sensitivity. And I just copied them over. And notice that I made sure, and I always make sure actually at this, that you can see my formulas inside this screenshot. I always tell students that when they ask me, I don't even know what to type here. Like, yes, you do, because I actually have the formula lit up. You see it right there at the top? It shows you what the formula has to be. So I just scrolled those down and highlighted them. The only modification I have to do is I have to manually type in 0, 0 at the top and 1, 1 at the bottom. And you see this pattern now of the points, like so. They rise up like this. This is called a receiver operating characteristic curve, or just rock curve is what people call it. What I want to do, okay, what is known is that to find the optimal cut point, what you need to do is go to the curve and find if this curve was perfect, if I was making a perfect diagnostic every single time, it wouldn't be a curve. It would be like a rectangle. So these points would be hugging up to the 1 at the corner. So what you do to find the optimal location is the one that's on the curve that's closest to that left corner point. And so you need to minimize the distance. You just had a quiz where you look for global and global maxes and mins. That's where the calculus comes in. You're actually calculating a minimum value. But you don't have a function. If you have your cell phone out, please put it away, or else I'm going to ask you to leave. Okay, so a minimum value, you don't have a function. And in real life, nobody's going to give you a function. Nobody ever comes and says, here's y equals x squared. Can you find the minimum for me? No, not ever going to happen. So you have to make up your own functions. And the way you do that is you usually have data. Everything starts with data. And then you go into Excel and you right-click that data. So I just right-click the data, like the actual points. So I went and right-clicked all the points. And this little thing comes up. This is a PC. I'm not sure if the same thing shows up on a Mac. Has anybody played around with a Mac and data? Does the same things happen if you? I don't even know if you right-click to get these things to show up. Is it right-click? Okay, so I hope that the same thing comes up. If you have a Mac and you have trouble, just shoot me an email and I'll try to figure it out with someone else who has a Mac. And you click Add Trend Line. And in the trend line, you have a series of choices. Like you could choose linear, you can choose a log function, you can just choose polynomial. Usually, I just go up to the highest value I can, which is 6. So I suggested that you choose a 6 order polynomial, but then I fit it there and I took one look at it and went, it's bad. It just didn't look good. So I went right back down. It ended up looking bad. So I went back down to order 2. So it's not just that I'm just fitting something mindlessly. I'm looking to make sure it fits the data well when I eyeball it. If I select these two things at the bottom, they give me 2 numbers. One of the numbers tells me how good a fit it is. That's R squared. The other number gives you the formula. It's the formula number you really want. And so I get both. And you can see here's the formula right here. There's now your polynomial. And here's my R squared. And what I want is I want to minimize the distance from the curve to that point over there. That point I know is 0, 1. And this curve, it's given by that formula. And now we're into calculus. There's the formula. I reduced it. I just made it so it looked a little cleaner, right? And reduced, rounded up figures. So here's the steps to find the optimal cut point. Here's my curve. The first step is to set up the distance function. Remember that from Math 100 and pre-calc? And you thought it would never show up again, especially in medicine? Here it is. I want the distance from the point 0, 1 to the curve. So my x1, y1, what's it going to be? 0, 1. x1's 0, y1's 1. That's the upper left corner. The second point, the point on the curve, the x2 would be just x, and the y2 would be found by plugging x into the formula I just found. Why is x not a number? Because I'm trying to solve for x. X is going to give me the optimal cut point. That's what it's going to do. That's the whole object of the game. Does that make sense? Unlike a fake problem, you actually have something you're looking for. You're looking for that optimal cut point. So you're trying to solve for it. Good? So there's my distance formula. How many of you like square roots? So just get rid of it. So the difference between solving a problem for your book or solving a problem for a quiz, I give you direction. I tell you have to have the y value. You have to give me both coordinates. You have to have the graph just this way. You know, I give you a lot of directions with all kinds of rules behind it. When you're doing an application, well, at least I do the absolute minimum possible just to solve that problem. And so I can get the same answer instead of minimizing distance by minimizing square of distance, because I don't need both coordinates. I just need the x coordinate. I'm just looking for the x value. And the same x value that minimizes the function also minimizes the square of the function. And I'm not going to go into theory, it just does. This is a cool thing. So I can work with that a little bit nicer looking function. So I want to minimize this. How do you find minimum of a function? What do? You just did it on your test, on your quiz right now. Right. You know, so one brute force, like quick way to do it is just graph that thing onto Desmos and see, you know, go and just go click right where the minimums are. You could do that. So you set f of x to be that thing up there and find the critical points. Look at that. I knew you were going to say that. That's why I split you guys up. So you could say that. There's my f of x. Find its derivative. Set it equal to 0. Solve for x. And you know what? This is an applied problem. I just want the answer so I can get that minimal cut point. I just stuck it onto a computer software and found the 0. You can do it on your calculator. On your graphing calculators, they will solve polynomial equations like this. You enter the equation, you tell it to solve. I recommend you do that on your calculator and just get the answer, because nothing looks pretty in an application. Look at those numbers. Have you ever seen those numbers in a pre-calc class? You don't see those. These are real life numbers. So I put it in Maple, and Maple gives you some stuff. They give you like negative numbers here, but this is the right answer. Around 0.25 or 0.26 is the right answer, because I'm working with x's above x equals 0, between x equals 0 and 1. So that's got to be the right one right here. So I just took that one. And I went back to my chart. X equals 0.25 is somewhere between these two numbers. And if I go back to my cut points, what's between 7 and 9? 8. So now I have a value. So what that tells me is, if people have a disease, the T4 is below 8, I will tell them they have the disease, and if T4 is above 8, I don't have the disease. So that's what I would tell them. I have the actual numerical calculated optimal cut point. And in fact, when we do models like this, that's what they tell the patients. What we're telling you, there's a mathematician over in New Jersey that actually did this by hand, and there's a bunch of theory behind it, so it works. That's it. That's what the psychologist tells me. He tells the patients. Like, so I scare my students with math, and you're scaring your patients with math. Real good. So are there any questions on methods? I think if you watch it over and you're doing it at the same time, it will work. But this might feel a little different than anything you've ever done in a math class before, because this is supposed to be real. Okay, so